The sandwich theorem. This is extremely important. You will see this in the future in this course. So if g of x is less than or equal to f of x is less than or equal to h of x for all x not equal to c in some interval about c, and the limit as x approaches c of g of x is equal to the limit as x approaches c of h of x is equal to L, then the limit of f of x as x approaches c is also equal to L. Basically, what this says is that if you have a function whose values are sandwiched or squished between the values of two other functions, then you can use that property to find the limit of the function. And this example will hopefully make that a little bit clearer. Example 3. Show that the limit as x tends to 0 of x squared times sine of 1 over x equals 0. So I mentioned before that it's often easier to find a limit if you have the graph. That's what we used in example 2. But here, this would be extremely difficult for you to graph quickly without a calculator. And as you know, on your AP exam, you will not have a calculator for half of it. So let's use the sandwich theorem to do this without the calculator. We know that sine always has values, its domain, between, that's b/n, between -1 and 1. And let's simplify this. Therefore, we know that the absolute value of x squared times sine of 1 over x is equal to the absolute value of x squared times the absolute value of sine 1 over x. And since sine is always between -1 and 1, the most that this will ever be, its absolute value, the biggest number that this will ever be is 1. Therefore, this, we could say, is equal to x squared times 1, or x squared. Okay. So this gives you the upper bound of this value, okay, of this function. The lower bound would be if you were taking the absolute value of x squared, that could have been a negative x squared. So a negative x squared times 1 would be a negative x squared. So the smallest that that would ever be is a negative x squared. This is less than or equal to our x squared times sine 1 over x, and that is less than or equal to positive x squared. Okay, so this function that we were originally looking at is sandwiched between these other two functions. It is always between them, and I'll show you that on the calculator in a minute, in case you're not sure of that. But right now, let's focus on actually finding the limit. The limit as x tends to 0, which is what we are trying to find, of negative x squared is equal to 0. So negative x squared is an upside down parabola And parabolas by default, mine's a little off center here, parabolas by default have their vertex at 0, 0. There's no plus or minus anything here, so this is just an upside down parabola with a vertex at 0, 0. As you approach x equals 0 from either direction, y also equals 0. The limit as x approaches 0 of x squared is also equal to 0. So I'm going to add another parabola over here in blue. The only thing different about this one is that it is right side up. So negative flipped it down, but the vertex is still at 0, 0. So no matter whether you're approaching from the left or the right, you are approaching 0. Well, sorry. As you approach x equals 0, the y is equal to 0. Okay, so because the limits of each of these functions that our function is between, the limits are both equal to 0, we can conclude by the sandwich theorem, the limit as x approaches 0 of x squared times sine 1 over x is equal to 0. Okay, and let's just pull up the calculator really quickly so we can confirm this graphically. Okay, so our function is x squared times sine 1 over x. Okay, so let's set our window to negative 0.2, 0.2, negative 0.02, 0.02. Okay, there we go. So that's a good graph for our function. And if we also graphed along with this x squared and negative x squared, you'll see how this is sandwiched between them. So here is x squared and negative x squared, and you can see that this function, the x squared sine 1 over x, never goes above the positive x squared. It never goes below negative x squared in this interval. So it really is just kind of bouncing off the edges there. And all three functions, as you get really close to x equals 0, y equals 0. So your limit for all three functions as x approaches 0 is 0. So that is the sandwich theorem. And that is actually, I believe that is it for this lesson. And we will continue with lesson 2 in the next video.